ever played with fridge magnets or tried to pick up pins using a magnet? Today, we will explore why magnets are so interesting and what they can do and some other amazing facts. Okay, so we can start this amazing chapter exploring the fascinating world of magnets. This chapter dwells into the characteristics, types, and essential principles governing magnets, emphasizing their dual poles and interaction with materials. So, what are those magnets? Magnets are objects that generate a magnetic field capable of attracting ferromagnetic materials such as iron, nickel, and cobalt. They can also repel or attract other magnets depending on their polarities. So, magnet is an object that attracts certain materials like iron, nickel, and cobalt. Magnetic field generations. The magnetic field is an invisible force that surrounds a magnet and affects the behavior of other magnetic materials and magnets within that field. So, if we take a magnet, there will be a magnetic field around that magnet. Those magnetic fields are invisible, so we cannot see that. They are invisible force that try to attract other magnets or other magnetic materials towards that field and they will attract together. Okay. So the magnet has two polarities. Those will be discussed in the upcoming slides. Okay, so now we are discussing about type of magnets. So these are all magnets. Okay, permanent magnet. Permanent magnet maintain their magnetic properties over time within a need for an external power source, making them ideal for various applications like refrigerator magnets and magnetic loads. So, there are permanent magnets and also temporary magnets. Temporary magnets are made from materials that can be magnetized but lose their magnetism quickly when an external field is removed, commonly found in tools like magnetic screwdrivers. So, in permanent magnets, they maintain their magnetic properties over time. They don't need an external power source. Without the need of an external power system, they maintain a magnetic property. But this temporary magnet is magnetized, okay, due to some external magnetic forces, and their magnetism will be loosed after the external force is removed. Okay. So in this case, permanent magnet needs an is or uh, does not needs an external system, but temporary magnets needs an external power source or a external magnetic field. Okay. So electromagnets are they generate a magnetic field only when electric current flows through it. Electromagnets are the magnets that produce a magnetic field only when an electric current flows through that thing, allowing them to be turned on and off, which is useful in devices like electric bells and cranes. Okay, so in this figure, we can see there are some magnets attached in this cranes. Okay, so there are permanent magnets, temporary magnets, and electromagnets. So, understanding the north and south poles of a magnet. A magnet inherently possesses two poles, the north pole and the south pole. These poles are always found in pairs. A magnet cannot exit without only a single exist with only a single north or south pole. So, a magnet has two poles, that is, one is north pole and other is south pole. No magnets cannot exist without only a single north or south pole. Neither it has north and south pole. Without any one pole, it cannot exist. Okay, so this is a picture of a bar magnet. Okay, so there is north pole and the south pole, and if north and north poles come together, the magnetic field tends to um, uh, tends to tends to move away from those magnets. Okay, so from north pole and north pole comes together, of two magnets come together, they tends to move further away from each other. When south pole and north pole are attracts together, they tends to move towards each other and they will attract each other. Okay, in this figure we can see that they are tends to move towards the magnet, but in this field we can see that they are moving slightly, moving apart from each other. Okay, so our earth is an also a magnetic field. It also have a magnetic field. Our earth act as a magnet, and around that earth there is a magnetic field. It's imaginary. Okay, so magnetic materials and non-magnetic materials. Magnetic materials such as iron, cobalt, and nickel exhibit a strong attraction to magnets. These materials can easily become magnetized themselves and are used in various applications, including motors and transformers. So, in motors and transformers, these magnetic materials are used. So, those magnetic materials are contains certain certain elements like iron, cobalt, and nickel, which exhibit a strong attraction towards the magnet. These materials can easily become magnetized. Okay, coming to non-magnetized materials, they include wood, plastic, and glass. They do not have any attraction to magnets. They remain unaffected when exposed to a magnetic field, are often used in situations when magnetic interference must be avoided. So the magnetic materials such as wood, plastic, and glass does not have any magnetic properties at all. Okay. So, magnetic compass development, key milestones in understanding and use of magnetic compass. So, in ancient time, the earliest use of magnetic compass data back to in ancient China when they used for navigation and divination. So, the in ancient times, they used for navigation and divination. For navigation, we know that from one place to another, they used to tend to find new places. So that is called navigation. And their divination is called a prediction of predicting future events by understanding certain signs, or sometimes like tarot cards, like craft, like astrology, those things. Okay. In Middle Ages, the magnetic compass became widely adopted in Europe, revolutionizing navigation at sea and enabling long distance exploration. For this, in Middle Ages also, they used for navigation. In modern era, advancement in technology has led to development of more precise magnetic compasses used to various applications. So in today's in systems like GPS, okay, geo positioning system, geographical positioning system, that is GPS, it is already installed in our cars, in certain applications, etc. Okay, so including aviation and GPS systems, modern era uses magnet. Okay, so we studied different uses of magnets in earlier times, ancient times, and middle ages and modern era. Okay, so, like poles repel, unlike poles attract. In previous slide, I already discussed that when two magnets approach each other, their interactions are determined by their poles. So, there are north pole and south pole. If the magnets have the same pole facing each other, such as north pole or south pole, they will repel each other due to its like pole interaction because they are like poles. North and north poles will repel each other. But conversely, if one magnet's north pole and south pole of another are facing together, they will attract each other. This fundamental principle of magnetism governs the how magnets behave in proximity to one another. This is already shown in the previous slide. Okay, so we know that like poles, like North Pole and North Pole will repel each other, but unlike poles, like the South Pole and North Pole will tends to attract each other. Okay, so come in. We already discussed this, and enhancing understanding through visuals. So, animation enhance learning. Visual aids like animation can effectively demonstrate and how magnets interact, making complex concept easy to grasp. So, I think that animation can makes people understand. I will introduce new animation videos later on our online classes. Later on our classes that be taken in YouTube. So illustrative images of magnets. I have already shown some images of magnets. So illustrative images of magnets shows their poles. Learners quick learn how to visualize the magnetic field and understand their properties. That I have already shown those figures. Okay. So this is an amazing chapter, and there will be more about this chapter will be in upcoming sessions. So I'm wind up in this session. So let's quickly recall what we have learned. So in this today's chapter, we learned about what are magnets and the difference between magnetic and non-magnetic fields. Two poles, north pole and south pole, magnets can attract or repel each other. So this the in upcoming sections we will discuss more about this chapters. So stay tuned for other topics.